Hello, today's video we are looking at composite figures again, but now we're going to be looking at three-dimensional composite figures. Our first video was just on 2D, the area of the composites. Similar to our 2D, with 3D, sometimes we're adding and sometimes we're subtracting depending on the picture in the diagram. Our first three-dimensional figure, we want to find the surface area and the volume. So when I look at this shape, I want to think, am I adding things? I'm subtracting things, and I'm going to be adding. I have two shapes. On the end here, I have a hemisphere, half of a sphere, and that hemisphere is connected to a cylinder. And there's the base of the cylinder over there. So we're going to look at surface area and we're going to look at volume. You have to do more than just think about formulas in this case. You have to think about what do you need. What is exposed? Surface area is all touchable area. Normally when we do a hemisphere, we take the sphere formula, we cut it in half and we add a base. But we're not going to be adding this base because this base isn't exposed. That base is connected to that cylinder, so it is not touchable surface area. So we're going to start with the lateral area of our hemisphere. Remember, we're not going to include the base because the base is not exposed. It's been, let's say it's been glued onto that cylinder. We can't touch it, we don't count it. A sphere is pi r squared. Because it's a hemisphere, we're going to cut that in half. So the lateral area for our hemisphere is 2 pi r squared. Again, there's no base exposed, so we're not adding that base in. We are given 16 as the diameter, which is going to make our radius 8. So this gives us 2 times pi times 8 squared. Don't forget we do 2 times 8 squared. We don't put the pi in our calculator. That gives us 128 pi meters squared. So we have that touchable area of the hemisphere in green. Now we want that touchable area of the cylinder. So I'm looking at the lateral area of the cylinder, not the total area, because the total area includes the top base and the bottom base. And that top base has been glued onto that hemisphere. It's not exposed, it's not touchable area. So we just want the lateral area of our cylinder, which is perimeter times height. The perimeter of the base of your hemisphere is a circle, and the perimeter of a circle is the circumference, which is 2 times pi times r. Different than 2 pi r squared, when I'm squaring it, I have that surface area. So that's 2 times pi. We already determined that the radius was 8, giving us our perimeter of 16 pi. This h is representing the height of our cylinder. The whole height is 30. But we know in a hemisphere, or in a sphere, our radius is the same in all directions. So this much right here is 8, leaving you with the height of your cylinder as 22. So it's 16 times 22, giving us 352 pi meters squared. Remember, again, we don't put that pi in the calculator or we get decimals. We want exact answers. So now I've got the touchable area of the hemisphere. I've got the touchable area of our cylinder. The last thing we need to do is add on that base. The bottom base is exposed. Even if I were to stand this up and it would be sitting on it, I could pick it up and touch the base. So I've got to account for that bottom base. I only have one bottom base that is going to be counted. And that bottom base is a circle. So the area is pi r squared. Again, same radius of 8, giving us our base area of 64 pi meters squared. Now the total surface area for this composite figure is all of those put together. So we've got the hemisphere, we've got the cylinder, and then we've got our base. When I add up all of those pieces, we end up with a total surface area of 544 pi meters squared. Sometimes I ask for exact and sometimes I ask for rounded. So we've got to make sure that we can plug that into our calculator and also get our rounded area. So make sure that you can do both. All right, that's the total surface area for our composite figure. Now we want the volume. The volume is everything inside, so we don't have to worry about touchable area bases. It's the hemisphere. I want the volume of that hemisphere. How much space is that taking up? The volume of your hemisphere, we only have the sphere formula, which is 4/3 pi r cubed. What happened there? But again, that's for a whole sphere, so we have to cut that in half. That gives us 4/3 times pi. Our radius has been determined multiple times, cubed, all over 2. Now this could cause some issues just with your calculator. So you just have to make sure that you can make this calculation. So we do 4 divided by 3 times 8 cubed. If I just do that calculation alone and then math bracket, I get 2,048 thirds. And we don't put the pi in our calculator. We then divide that by 2. If I take that and divide that by 2, not with the pi, I get 1,024 pi over 3. And that's our volume, meters cubed, of our hemisphere. Cylinder is much easier. The volume of our cylinder is base area times height. We already have the base area from when we added the base and surface area, which is 64 pi. The height of our cylinder we determined when we did the surface area is 22. So we get that the volume of our cylinder is 1,408 pi meters cubed. We have those two shapes. For our volume, we add them together. So the volume of our hemisphere plus the volume of our cylinder. Remember, we add the fraction, the whole number, we leave the pi out. We add that back in at the end, which gives us 5,248 pi over 3. That would be our exact answer. If I also asked you for the rounded, you would plug that into your calculator, end up with 5,495.69 meters cubed. We want both calculations so that you are prepared for the directions given on your test. All right, our last one, we want to find the volume. So when I look at this, I want to think about this as a toilet paper roll or a paper towel roll. We see this shape. The inside is empty. Think about a paper towel roll. You roll all the paper around that cardboard and the inside is hollow. So our plan of attack here, the volume of our composite shape is the volume of our big cylinder minus the volume of the small cylinder. The cylinder shape, the volume of our big one, is base area times height. So if I look at the big cylinder here, the base is a circle, so the base area is pi r squared times the height of the cylinder. Our radius for the big one is 18. The height of this paper towel or toilet paper roll is 12. Just like before, ignore the pi for now. 18 squared times 12 is going to give us 3,888 pi inches cubed. We put that pi back on at the end. Then we look at the smaller cylinder that we're going to be cutting out. So the volume of our small cylinder, it's still a cylinder, so it's still base times height. The base is still a circle, so it's still pi r squared times the height. Now in the small one, your radius is 9. It still has the same height because it's still extending for that same distance as the big one. We do 9 squared times 12 to get 972 pi is put right back on at the end. So the volume for this composite shape, we have to take the big cylinder, subtract out the small cylinder. When we subtract those two, we get that our volume is equal to 2,916 pi inches cubed, which is about 9,160.88 inches cubed. All right, that is it for your 3D composite.